to lecture 28. So, we continue with whatever we have been doing last time. So, we were interested in deriving certain relation, and that relation was tan theta by 2 equal to E plus 1 divided by E minus 1 tan hyperbolic f by 2. So, this we have to derive. So, to derive this, what we need to do, that we go back and look into this equation. We have written cos hyperbolic f equal to E plus cos theta divided by 1 plus E cos theta. This we have derived in the last lecture. Okay. So, rearrange this equation. This becomes cos hyperbolic f plus E cos theta times cos hyperbolic f, this equal to E plus cos theta. Cos theta term we combine together, one minus E cos hyperbolic f. Okay. So, from here we get cos theta equal to cos hyperbolic f minus C divided by 1 plus E cos hyperbolic f. Rewriting the left hand side, and the right hand side the same way, cos hyperbolic f minus C divided by, use componendo dividendo. So, we have here 1 plus tan square theta by 2 minus tan square theta by 2 this will be equal to just rewriting the whole thing. One minus E, and here minus cos hyperbolic, this is gets to minus minus plus, one minus C here we have to check this particular part. Okay. Here this is 1 plus E, 1 here in this place, and this is minus minus, that gets plus. So, this is 1 plus E, and thereafter we have cos hyperbolic f we have taken outside. So, this is minus, this minus minus plus. So, this part is okay then, and here also need to change 1 minus e and then plus 1 plus e. Something wrong here. We'll go on the next page. So, left hand side is 2 tan square theta by 2 divided by 2, and on the right hand side we have 1 minus e, this is 1 minus e, here we are doing the mistake, this is 1 minus e, here this is 1 minus e, 1 minus e. So, I will strike it off this particular part. With this the things will get modified. So, we write it on the next page, 1 minus e cos hyperbolic f, and then minus cos hyperbolic f minus e, minus cos hyperbolic f minus e, cos hyperbolic f plus cos hyperbolic f minus e. This is the right thing now. So, tan square theta by 2 1 plus e, and then here minus sign, if we take it outside. So, this is 1 minus e 1 plus e cos hyperbolic f. You can check, and thereafter this becomes 1 minus e, and here in this place plus 1 minus e cos hyperbolic f, 1 plus e can be taken outside, and here 1 minus e can be taken outside. So, this gets reduced to 1 minus cos hyperbolic f and divided by 1 plus cos hyperbolic f. So, tan square theta by 2, this gets reduced to 1 plus e So, we need to rearrange this part. This quantity is 2 times cos square hyperbolic f by 2, and similarly this part we can express here 1 plus cos hyperbolic f, this we can rearrange as we can rewrite as minus cos hyperbolic f, and say here we write it as 1 minus cos hyperbolic f. So, here if we break the bracket, so this gets reduced to minus 1 plus cos hyperbolic f, and if we write here 2, so this will reduce into this format. So, then this becomes 2 minus cos hyperbolic square f by 2. So, 2 times 1 minus cos hyperbolic f square f by 2, and this is nothing but minus 2 times sin hyperbolic square f by 2. Because we are using this expression sin hyperbolic square f equal to 1, or say this is x or any quantity here, sin hyperbolic x minus cos hyperbolic square x minus sin hyperbolic square x equal to 1. So, following that notation we get this expression. So, here we can write with a minus sign 2 sin square sine hyperbolic square. So, this gets reduced to e plus 1 divided by e minus 1 tan hyperbolic square of this part we need to correct here also. This should come in the format. Here we have done one mistake here. Okay, so this will ultimately come here in this format, tan square theta by 2, which we can write as tan theta by 2, this equal to e plus 1 by e minus 1 under root tan hyperbolic square tan hyperbolic f by 2, tan hyperbolic f by 2. So, the remaining part we have to work out 1 minus cos hyperbolic f and 1 plus cos hyperbolic f. Okay, so, analogy is the same. That means, if you remember from our trigonometry that 1 plus cos x is nothing but 2 times cos square x by 2. So, the same analogy also applies here in this place. Okay. So, if we follow that, so here in this place this is your 1 plus cos hyperbolic f equal to 2 cos square cos hyperbolic square f by 2. Okay. And then this part we can rewrite as 1 minus so we want to first express it this way. So, cos hyperbolic we have this part we are trying to express here. So, here we write 2 minus 1 plus cos hyperbolic f, and then see that this gets reduced to this format 1 minus cos hyperbolic f, and this quantity, as you can see this quantity here, this can be written as 2 minus follow using this 2 cos hyperbolic square f by 2. So, 2 times 1 minus cos hyperbolic f by 2, and this is 2 times, this will come with a minus sign here. So, minus sin hyperbolic f by 2, as we have not written here. Okay, anyway, this part is directly coming from this place. So, from this equation, so you can rearrange and check it. So, we have to keep care of that the identity we are using, it is almost similar to what we have the trigonometric identities in the case of a unit circle. So, in the case of hyperbola, it follows the almost the same rule. So, 1 plus cos hyperbolic f equal to 2 cos hyperbolic square f by 2. So, we utilize it and insert it here. In that case, you can see that 1 plus cos hyperbolic f, this becomes from this place, this goes as 2 cos hyperbolic square f by 2, which is written here. We have written the opposite way, here we correct. Cos hyperbolic square f by 2, and this part, this goes here in this place with a minus sign. So, minus sign we have absorbed here, and thereafter we reverse the sign of this. So, 1 minus e, this becomes e minus 1, and finally, we get this equation. So, this is what we were looking for. So, this is proved in the case of hyperbola, this result we were looking for. Now, one more thing I would like to mention here before we further proceed, that while we derived this equation t minus t times m h. So, at that time we got plus minus f minus e sin hyperbolic f, and then we selected the minus sign, and thereafter we wrote this as t minus t equal to e sin hyperbolic f minus f. So, minus sign was accepted only and plus sign was rejected. The reason for this is the consistency in the result. Okay. The if actually this f is defined in terms of area, which is my next topic to discuss. Okay. So, this way the area below this is negative and the area upside that will be positive, okay. And accordingly your mean hyperbolic this hyperbolic mean anomaly, this will be positive and negative, either corresponding to this one this the f, the quantity f that we are writing here. So, this is defined in terms of area of the certain area which is projected on the hyperbola, which I am telling that I am going to discuss. So, this is the consistency of, we are looking for the consistency of result. So, if f is positive, so corresponding m we are looking for, the m should also be positive. So, for making that we take this negative sign, you can check it numerically. Okay, this negative sign is selected and we put it here in this format, which is our Kepler's equation for hyperbola. Kepler's equation for hyperbola. So, this part you should remember also, while we have written use this format, and this result is independent of whether we are using the format for L equal to A times 1 minus E square, or the other way, either we are using the expression for the r where A is greater than 0 and the expression for r where A is less than 0, both for the case of hyperbola. So, independent of that we are getting this expression here, and also we have looked earlier that in the case of hyperbola, using the one integral standard integral we used, and in that we inserted the equations we derived. So, thereafter we got this expression. So, both way we get the same expression, which we have done in the last lecture. So, now after winding up this part, let us go into and look into the what is this f, which is pending for a long time. Okay, so here it has not passed through the, this line is little curved, but this is passing through this origin. Here this is the focus. The if here does not have much meaning in the case of hyperbola, just as the mean anomaly. So, this is hyperbola and this is a rectangular hyperbola. Rectangular hyperbola is the case where a equal to b, and that corresponds to e equal to root 2. So, you can look into this expression b equal to a times e square minus 1. So, if you put e equal to root 2, so this gets reduced to 2 minus 1 equal to a. So, b equal to a. So, this is the case of the rectangular hyperbola, and this is the asymptote to rectangular hyperbola. Now, why this f is not defined as in the case of E is defined in the case of ellipse, the eccentric anomaly? The reason is very simple, that in the case of ellipse there was a circumscribing circle which we called as the auxiliary circle, which in this case is not present. Okay. And therefore, instead of defining this in terms of circle, we utilize a rectangular hyperbola. So, this is your rectangular hyperbola. And if a equal to 1, so this is called the unit rectangular hyperbola. So, this concept is used for finding out what we are looking for, the f, how it is described. The inner circle we will show it by some other color, by this hyperbola. And this hyperbola also, both of them they touch here at the perigee. From this place, draw this R, this is your R, and then draw a perpendicular and pull it up also. This is your theta, and this one is already we have written, this is the rectangular hyperbola. So, rectangular hyperbola, it goes and cuts here in this point. Now, to this join here, this is not a very good figure. Okay. Rectangular hyperbola, again I will redraw it, it looks something like this. Okay, say so, asymptote is different. So, I will remove the asymptote. This asymptote line I am removing. So, in the case we of the ellipse, we wrote this as P, this as M, and the upper one was perhaps written as M, and the lower one was N. Now, this area which I am hashing here, this area bounded between this red line and this black line for the rectangular hyperbola and this axis, okay. It is shown by green line here. This is used to define f. Say analogy is given for the case of a circle. So, in the case of a circle, if this angle is theta, so area of this sector will be given by, and if this is r, so r square theta divided by 2. This is the area of this sector, and if r equal to 1, that means the unit circle. So, in that case, this area delta A, if we write this as delta A, so delta A becomes equal to theta by 2, means this area is direct representation of this theta. Similarly, this analogy is made here, and whatever the area I have shown by this hashed pink line, okay, that area is used to represent f. So, as such, just like the eccentric anomaly, we do not have the concept here of a particular angle here in this case. Okay. So, you can see from this place that for the case of the rectangular hyperbola, this hashed area in pink, this can be written as, if we write this point as O, so area M N O, which is a triangle, minus area, and this point we write as, this is the perigee point. So, let us make this as say we write here as D. Okay. So, M D and N. So, this is referring to rectangular hyperbola. We are trying to find area for this rectangular hyperbola, and this rectangular hyperbola, if it is unit hyperbola, means A equal to 1. So, the things gets more simplified. So, coordinate of this point here in this point, and this is x y. So, what will be the area of the shaded region? So, area in pink which is M O D, this gets equal to, this coordinate is x y. So, therefore, you can see that this is x y divided by 2 and minus the area inside the hyperbola, means we have to draw a area like this, elementary area, and integrate it, and this point if we write as 1 in the case of rectangular hyperbola. So, this is your A equal to 1. So, from this point to this point, then we have to integrate, where this is the point we are writing as x. Okay. So, then this area becomes, and we know that this hyperbola for rectangular, if it is, so A becomes equal to 1. So, in that case it will be written like this, and therefore, y becomes x square minus 1 under root. So, upper curve can be written like this. Similarly, for the lower curve also, but that will come with a minus sign. So, this becomes then y dx to be integrated from 1 to x. Therefore, area M O D x and y equal to, already we have written here x square minus 1. So, we replace here x square minus 1 divided by 2 minus under root dx y dx. Now, this area, the area shaded in pink, okay, this quantity, if the area, say we have already written here delta MOD. So, delta MOD, this is the area times 2 divided by A square, this is defined as, F is defined like this. So, this is the area here, pink area, multiplied by 2 divided by A square equal to F. In the case A equal to 1, so we have F equal to delta 2 times delta delta MOD so this angle is, F is defined as twice the area which is shown here in pink. Okay, so this definition is not as you can corroborate something from here, that this area is numerically equivalent to, in the case of a unit circle r equal to 1, this area is equivalent to theta by 2, means this angle theta is nothing but delta A times 2. Similarly, here in this case, this angle F is 2 times delta MOD, but here in this case see that this directly, this is the angle here which is represented, this is your theta angle, this is your theta angle. But here in this case we are not telling that this angle is the F angle. So, let us go further, then we will look what the exactly the things are happening here. So, x times x square minus 1 divided by 2, and this part, it is a integration, it is a standard integration given in many of the books. So, you can use it on the integral. So, x times x square minus 1, and also on Wikipedia you will find some of this material. Okay, so, you can refer to that also. And once we rearrange it, we get it as 1 by 2 ln x plus x square minus 1 under root so this is the area, and twice the area delta MOD, this we are defining as F. So, F becomes then equal to ln x plus x square minus 1 under root. So, this is a very abstract representation here in this case, but it helps in solving out certain problems. Now, we know that this quantity is nothing but e to the power f and therefore, e to the power minus f will be 1 by x plus x square minus 1 under root. And if we try to rearrange this and write it like this, e to the power f plus e to the power minus f divided by 2. So, from here we will get this as this is nothing but the cos hyperbolic function. You can see that this gets reduced to square minus 1 plus 1 by So, we have from this place cos hyperbolic f, this equal to 2 x square one cancel out, 2 x square plus 2 x times x square minus 1 under root divided by x plus x square minus 1 under root. X taking out, this is a common, and here the factor 2 we have taken. So, first let us remove this factor 2 here. So, this is only this part first we have written here. So, e to the power f plus e to the power minus f. Okay, no, first if we write divided by 2 only, then this cos hyperbolic f we can write. Then in that case we need to write here 1 by 2 and take it inside the bracket, the whole thing. So, we have to take it inside the bracket, divided by 1 by 2, this is 1 by 2. So, here also we need to put 1 by 2, then 1 by 2 and then 1 by 2. So, this gets reduced to finally cos hyperbolic f equal to x. So, this means what we have proved, that we started with f equal to ln x plus x square minus 1 under root, and then from there we proved that x equal to cos hyperbolic f. Okay. Similarly, the same way you can also prove another expression. So, let us say we write in terms of sine hyperbolic f, this equal to, or we write in a different way little, ln x plus x square plus 1 under root, this quantity we can write as f, or you can use a different notation, maybe if you write in terms of y, and the way we have proved here in this place, the same way here it can be written as. So, here f then becomes cos hyperbolic inverse x. So, in this place then f becomes sine hyperbolic inverse x, and this is left to you as an exercise. So, thus what we have concluded, that the quantity f we are using here, somewhere in some of the text it may be represented by h. Okay. So, this quantity f, this does not have a physical meaning as the eccentric anomaly E. This is basically a mathematical quantity, and this is more of it is represented in terms of the area which is shown here in the pink, and this part also you remember. This is 2 times the area divided by a square, and only in the case of a rectangular hyperbola where a equal to 1, okay, f becomes equal to 2 times area. So, case of a hyperbola has turned out to be little different from what we have done for the ellipse, but if you go in a mathematical way, so it is not much difficult. In the case of the geometric representation, it becomes little complex, because there is no auxiliary circle and we have to use this hyperbola. So, this is the this pink area, this is the projected area, sometimes called on the hyperbola, Okay, so we will continue to discuss about maybe one problem we can take up later on in the next lecture. So, we will conclude this lecture here, and next time we will start with the 3 body problem, and we will also consider taking one problem related to hyperbola. Already we have done one problem, and regarding ellipse also we have taken one problem related to the sun earth. This there where we have proved that moving in the ellipse and the time taken to cover this blank area, it is this the again this pink area here, this will be t by 2 plus 2, means the 2 days more than the half of the period of the earth around the sun. So, this problem we took. So, this way once you know the basic mathematics, some of the basic mathematics you need to remember also, because every time we cannot derive. Okay. It is not possible that every time we go and work out, or either you can have a chart and work out the whole thing using a chart. So, but if you remember few of the equations, it becomes very easy to do the problems, and the whole thing becomes speedens up. Okay, so, we will conclude this lecture here in this place and continue in the next lecture. So, next lecture maybe we can take on one problem, and also we are going to start with the 3 body problem, and restricted 3 body problem, thereafter it will follow. Thank you very much.